Greetings. We are from Group 2, Section 1, and presenting Jimah East Power Plant as our project. Next slide. And as for group member, I am Jason Anthony Alalaki Don Bosco, and thus we have Muhammad Aiman Haziq bin Kamaru Anwar. We have Muhammad Shami bin Muhammad Zalifuddin, and we have that's our third presenter, and we have Abdul Wafi bin Muhammad Subiri as our last presenter. Next slide. Now I will pass to Aiman Haziq.
So, firstly, I will explain about the background of the Jimah East Power Plant. Jimah East Power Plant is also known as the Tuanku Muhris Power Station. It is a 2 gigawatt or 2000 megawatt ultra supercritical coal-fired power station that located in Port Dickson, Negeri Sembilan, Malaysia. So, Jimah East Power Plant consists of two generating units, which each of them producing up to 1000 megawatt, giving a total power output of 2000 megawatt. This makes it one of the largest coal-fired power plants in Malaysia. So, Jimah East Power Plant is owned and operated by Jimah East Power, which is DAP, and a joint venture of Tenaga Nasional Berhad TNB, Mitsui, and Chugoku Electric Power. The first unit of the Jimah East Power Plant commenced commercial operation in August 2019, while the second one is December 2019. Now, I will explain about the detailed specification of the Jimah East Power Plant. For the fuel types, Jimah East Power Plant imported bituminous coal primarily sourced from Indonesia, and it consumes almost approximately 6 million tons of coal per year. For water resources, Jimah East Power Plant get the raw processed water obtained via 220-kilometer dedicated pipeline, and the condensed cooling water is sourced from salt water drawn directly from Malacca Strait. And for power evacuation, the power is transported via a 46.65 kilometer long, 500 kilovolt double circuit overhead transmission line connecting to a substation. And for the emission control system, Jimah East Power Plant use a FGD system and ESP system. So that's all from me. I will pass the next slide to Jason.
Thank you, Ayman. And now let's go to thermodynamics parameters and temperature. First, it's an ultra superficial steam parameter. The main stream temperature is 603 degrees Celsius, and the main steam pressure is 270 bar of pressure. This is what that makes it unique and special from the basic and conventional coal system. Because of the 603 degrees Celsius of temperature, that's what gives the system efficiency of 40 percentage, which means in Malaysia, this is the highest efficiency plant thermal. And it also has a thermal input of 5000 megawatt. It is not stated in anywhere, but we use the formula of efficiency is equals to thermal input over thermal output. As we know, the thermal output is 2000 megawatt by TNB, and 40 percentage also mentioned on many news and TNB. As for the engineering operating system, we have the main steam boilers at 603 degrees Celsius. After expanding through the boiler, it through the turbine, and the steam temperature decreases significantly before entering the condenser. The condenser is about 35 to 40 degrees Celsius, and then the flue gas stack later is approximately at 120 and 150 degrees Celsius. Next slide. Now let's jump into thermal energy balance breakdown, which is two units. Now we are showed in percentage and also in unit of megawatt. The total thermal input is 5000 megawatt. And then the condenser rejected 2295 megawatt. There are also like losses like stack gas losses, which is about 300 megawatt. This is all approximation. And also there's other losses for 880 megawatt, and also a gross power output of 2325 megawatt. So this shows like in thermodynamics that the energy balance demonstrates that the significant portion of the fuel energy cannot be converted into useful work due to thermodynamic limitations and system losses. Next slide. As for the electrical energy balance breakdown, The gross power output is 2325. Now, this is only an approximation since can be stated only 2000 megawatt is produced by the power plant. And we approximately calculated around 325 on auxiliary power consumption system. Some of the system you may ask is boiler feed pump, water pumps, cooling water pumps, forced draft pumps, induced draft pumps, coal handling system, and ash handling system. Now I give the presenting to Shami.
Thank you, Jason, for your brief explanation of the power plant. Next, we'll be moving on to discuss about the stack gas losses for the Jimah East power plant. For the short definition of this, the stack gas losses refer to the thermal energy carried away by hot flow gases leaving the chimney. And as we try to do the brief explanation of this, we all know that not all heat that is released during the combustion could be converted into useful work, and some portion of it would leave the plant through the exhaust stack. And by this, we could know that the lower stack gas losses will improve the overall plant efficiency eventually. And the percentage of losses that is typically would be around 5 to 8% of the fuel energy input based on the modern ultra supercritical coal plants benchmark. And as our calculation were made, the estimation on the Jimah East power plant would be around 300 megawatt. And we'll moving on to the next slide, which is the heat rejection at condenser. For the condenser, it would remove the unused thermal energy from the steam, and the rejected heat would then be transferred to the cooling water and released to the environment. This is a necessary step to complete the Rankine cycle as it allows the steam to condense back into water. And based on the formula that we use, we could know that Q out equals to the Q condenser plus the Q stack and Q others. That would give us around 2,675 megawatt. And the plant also operates at approximately at 40% thermal efficiency. And to double check the Q out of our calculation, we could know it by using the formula of Q out equals to Q in minus the W gross. And we could see that we got the amount of around the same, which is 2,675 megawatt. So we could conclude that we estimate the Q out for the heat radiation correctly. And then I would pass the next slide for Wafi.
Thank you. Now, I will talk about environmental effect of coal power generation. First of all, for air quality, coal combustion release harmful gas like nitrogen oxide, which cause acid rain. To fix this, Jimah power plant use advanced FGD system and low nitrogen oxide burner to drastically cut down this emission. Second, we have thermal pollution. The seawater used for cooling is discharged 7% hotter than normal. This affects marine life. So, the plant continuously monitor the water to comply with environmental standard. Lastly, greenhouse gases. Every kilowatt hour of electricity generate release about 0.9 kilogram of carbon dioxide, which contribute to global warming. Moving to the next slide, I will talk about discussion. Jimah East Power Plant is actually one of the largest coal fire plant in Malaysia, generating a total capacity of 2,000 megawatt of electricity. It uses supercritical technology to boost efficiency up to 40%, combined with emission control system like FGD and ESP. It successfully reduced environmental pollution. Moving to the last slide, which is conclusion. To conclude this, Jimah East Power Plant is a highly reliable source of electricity with high generation capacity. Even though coal combustion has its environmental impact, the advanced technology used successfully minimize pollution and support a more sustainable operation. That's all from me.
Okay, thank you, Wafi. That's all from Group 2. Hope you enjoyed the video and thank you, everyone.